Yes.
Good. How are you? Hello, can you hear me? Hello, Adito. I can't hear you, Adito. Can you hear me? Hello. Okay, I'm gonna mute because your mic has static behind it, okay? All right, so I'm going to read the story with you today. Adito, do you have any questions for me? If you have any questions, raise your hand, okay? It's only you and I in the meeting today, so I'm going to read the story with you, and then I'm going to post it for your classmates, okay? All right, so if you have a question, please raise your hand to let me know that you have a question. Adito, can you hear me? Hello, Adito, can you hear me? All right, I think that everything is working. All my signals say that everything is working. I think maybe there's static behind yours. We're going to read the story together, okay? All right, thank you for joining me, Adito. All right, you're the only one here, just you and me. Oh, Adito's gone. Okay, maybe no connection for Adito? All right, I'm going to read the story for you. I'm having the meeting and no one is here to ask questions, so I'm going to read the story for you. Okay, our story this week is narrative nonfiction. Our genre is narrative nonfiction, a crash course in forces and motion with Max Axiom, super scientist. This is Max, okay? Max's real name is Maxwell J. Axiom. He lives in Seattle, Washington. He's 6'1", brown eyes, 192 pounds, and no hair. Okay? He has super capabilities. Remember we said capabilities are the abilities to be able to do something. Okay? So super intelligence is one of his abilities. Able to shrink to the size of an atom, which means he can get very, very small. His sunglasses give X-ray vision. His lab coat allows for travel through time and space, okay? So this is Max. His origin, since birth, Max Axiom seemed destined for greatness. Everybody knew he was going to be something special. His mother, a marine biologist, taught him about the mysteries of the sea. His father, a nuclear physicist and volunteer park ranger, schooled Max on the wonders of earth and sky. One day on a wilderness hike, a mega-charged lightning bolt struck Max with blinding fury. When he awoke, Max discovered a newfound energy and set out to learn as much about science as possible. He traveled the globe, earning degrees in every aspect of the field. Upon his return, he was ready to share his knowledge and new identity with the world. He had become Max Axiom, super scientist. Forces that move us. What a perfect day. Super scientist Max Axiom jumps right into the world of forces and motion at the amusement park. Squall! This is the bird, okay? Squall! Even though everything feels turned upside down. So he says, what a perfect day, although everything feels turned upside down. He's hanging upside down from the court. Spinning, flying, jumping, and falling are just some of the amazing ways to move. But there's a lot of science behind the zoom around us. In fact, the world is full of all kinds of motion. Everything that moves needs a force to get it moving. Back for another jump already? You bet. A force is any push or pull on an object. Bungee jumping depends on a force called gravity. It pulls objects towards each other and it keeps us on the earth. Remember, gravity is the pull that keeps us down on the earth. Okay? Gravity is the reason I fell down, not up or sideways. When he jumps, he falls down because gravity pulls him down to the ground. He doesn't go sideways or back up, he goes straight down. Okay, that's gravity. Phew, moving can be thrilling, but I need a break. Snap, snap. Hi, Rosita. What are you doing here? Hello, Max. I'm taking notes for the physics class I teach. Why are you just sitting there? Is something wrong? Once I sit, sometimes it's hard to get moving again. But once I get going, I often can't stop. That's inertia for you. Here we have thrilling. Don't forget thrilling means exciting. That's inertia for you. An object at rest tends to stay at rest. An object in motion stays in motion. That's Newton's first law of motion. A still object needs a force to get it moving. Okay, what does that mean? That means that when something is sitting still, it stays sitting still until it is pushed upon by something else, okay, when it's hit by a force. Likewise, a moving object needs a force to change its direction, slow it down, or make it stop. For instance, inertia keeps that stroller rolling. See the stroller going down the hill? Inertia keeps it going, meaning that when an object's in motion, it keeps moving until another force comes along to stop it, and that's Dad. Dad grabs the carriage and stops it, and the kids say, "Oh," because they were enjoying wee down the hill. To cure your inertia, you just need a little push. Come on, let's go ride the roller coaster. Let's move. So she gives him a push and tells him to move. We have here a sidebar at the top, Isaac Newton. Isaac Newton, it mentions here Newton's law. Isaac Newton was a scientist born in 1643 and he died in 1727. He was the first person to realize that certain laws of nature explained all motion on Earth and in space. He also was the first to explain the idea of gravity. Okay, here he mentions his law of motion. All right, here we go, click, clack, click, clack, click. I feel like I'm being pushed to the back of my seat. That's inertia. When the ride starts, your body is at rest. When the chair moves forward, your body wants to stay at rest, but the chair moves into you. So when you're sitting, your body is still. The chair starts to move and your body wants to stay still. That's why you push against the back of the seat. The chair's forward motion makes you feel like you're being pushed to the back of your seat. Wow, how does this roller coaster go so fast? The force of gravity is increasing our speed. See, they're going down, so gravity is pulling them down. Speed is how fast we are going at any given moment. Acceleration is how much speed we pick up as we go down the hill. Acceleration causes us to move more quickly at the bottom of the hill than we did at the top, okay? So they accelerate, they get faster as they go down. That bar digging into my stomach must be inertia too. You got it. See, that bar is staying still, and when your body pushes forward as you stop, it feels like the bar is pushing into you. The ride comes to a stop, but your body wants to keep moving. The lap bar applies a force that keeps you from flying out of the car. Okay, so this bar keeps us in place. So the lap bars stopped us from continuing forward on the roller coaster. What keeps that stone from staying in motion? See this rock that's going across? There's a stone bouncing across. Excellent question. You can't see it, but it's a force called friction. But a force called friction stopped the stone. Friction happens when two surfaces rub against each other on Earth. Gravity and friction work together to slow things down and make them stop. Today in class, we rubbed our hands together to show what friction was and how when two objects touch each other, they slow each other down, okay? We discussed the brake on your bike and how when the brake touches the wheel, it makes the brake makes your bike slow down. Brakes on the roller coaster use friction to slow us down too. Come on, I'll show you. Each roller coaster car has two brake fins attached to the underside. These are the brake fins. These fins slide between two sets of brake rails. I see when the brake rails squeeze against the fins, friction stops the car. When they squeeze together, the friction makes the car slow down and come to a stop. I had a great time, Rosita, but I've got to run. My nephew is having his party, his birthday party, over at Skater's Paradise. See you later, Max. Juggling these bowling balls is wearing me out. I don't know why that guy is so tired. Juggling is easy. Look at the big balls and look at the small balls. The juggler on the right is tired because he is using more force to throw and catch heavier objects. He's showing us Newton's second law. The amount of acceleration that a force can produce depends on the mass of the object. What mass, Uncle Max? Mass is the amount of matter in an object. The bowling ball has more matter in it than the tennis ball, so it feels heavier. Think about it. Which ball would be easier to juggle, Nick? Okay, so of course it takes more force to move the big balls than it would to move the small balls. Okay, let's read the sidebar here about gravitational pull. Weight is different from mass. Weight is determined by gravity's pull on an object. So weight is the amount of pull it takes to keep the object down on the Earth. Each planet in our solar system has a different gravitational pull. If you travel to each of the places below, your mass would always be the same, but your weight would be different. See, each one has a different gravitational pull. So the amount of force it takes to keep you down on the surface would be different, which means you would have a different weight. Multiply your weight by the number shown below each planet to find out how much you would weigh there. If you weigh 100 pounds on Earth, you would weigh 38 pounds on Mars and 236 pounds on Jupiter. I have another way to think about Newton's second law. I need 2 volunteers. Pick me, I'll do it. I'm going to push both of them with the same amount of force on a level surface. Who do you think will accelerate faster? Remember, accelerate means to speed up. So he's going to push the boy and the girl at the same time with the same amount of force. He's go faster. Jenny Austin skater went. Both of my arms are equally strong, so the amount of force will be the same. Let's see who gets a faster start. Like the tennis ball, Jenny has less mass than Johnny, so she gets a faster start with the same push. Johnny would need a stronger force to get moving as quickly. Remember, the big balls and the small balls takes more force to move the big balls than it takes to move the small balls. The same thing with the 2 characters. The girl is lighter, so it takes less force. The boy takes more force, okay? I'm like the tennis ball, the girl says, and the boy says, does that make me a bowling ball? Uncle Max, Jenny won the race on a flat surface, but I've noticed that the bigger kids always travel farther than the smaller kids when skating down a ramp. Sometimes having more mass can give you an advantage. Remember, we said an advantage is something that helps you. Let's have Johnny and Jenny race again. In the last race, we wanted to see who would get a faster start. This race is for distance. I'm going to release you at the same time. We'll see who travels farther without pumping. Johnny's got it in the bag. No way Jenny will beat him easily. So they're both going to come down the ramp at the same time. Did you see that? Do you see that? Gravity pulls them down the ramp, but Johnny travels farther than Jenny. Max, what happened? I got a good start, but Johnny passed right by me. Johnny's larger mass takes more force to slow down or stop than your smaller mass. Because she's lighter, it takes more mass to stop. It takes more force to stop the heavier mass. Okay, so Jenny slows down faster because she's lighter. Johnny takes longer to slow down. Okay, friction between your wheels and the ground was the main force slowing both of you down. Johnny needed more friction to stop, so he traveled farther. Remember how we talked about the friction, two objects rubbing together? Their skates are rubbing against the ground, and that's what causes them to slow down. Time for cake. I don't think these kids will let a little friction stand between them and chocolate cake. All right, and that's the end of our story. Okay, so this is our story for the week. Tomorrow in class, we will discuss it. Tomorrow for the students at home, I will make a video where we discuss the main points of the story. And let me just check to see if Adito, can you hear me, Adito?
Yes.
Hi, Adito, did you hear the story?
Yes.
Did you have any questions for me, honey?
No.
No? Do you understand the story and the vocabulary?
Yes.
Okay, sweetheart. All right, so that's it for today. I just read the story. Do you have questions about anything else? Any other questions, Adito, about anything else? Hello? Do you have any other questions for me? Oh, you muted yourself. Here you go. Here you go, honey. Hi. Do you have any other questions for me? Hello?
No.
No questions? All right, honey. I'll see you next time, okay? Bye-bye. Bye-bye, Adito. Bye.